In this segment, we're going to be talking about properties, both intensive and extensive, states and processes which connect two states together. So let's start with the properties. Property is a characteristic of the system, and you're already familiar with several properties. You're familiar with temperature, and we're going to be working with SI and English units in this class. Many times we'll have a need to convert to units of absolute temperature. So in SI units, that's Kelvin. You'll notice it's not degrees Kelvin, it's Kelvin. And you're just going to add 273.15 to whatever your temperature is in units of degrees Celsius. A lot of times in class, I'll just round it off to 273. But if you need to be more accurate, just leave it at 273.15. In English units, it's degrees Rankine. And you'll add 459.67 to your temperature in degrees Fahrenheit. Oftentimes in class, it just rounded off to 460. But once again, if you need to be more accurate, just leave it as 459.67. All right, so temperature. We'll also work with pressure and volume. So there we go. We've got three properties that we're familiar with already. So temperature, pressure, volume. All right, conversion factors. You're not going to be able to survive engineering without knowing how to do simple unit conversions. So I would encourage you when you're studying, please don't try to rely on Google because you won't have Google on the test. So you will always have access to these conversion factors on a test. You just need to know how to use it, and it just takes practice, okay? So if you're not really familiar with it, there are lots of good YouTube videos out there. I'm always happy to answer any questions that you have, but learn it early, and that way you take the mystery out of it, right? All right, so let's get some practice. So we're going to convert 0.5 feet cubed to inches cubed. And if you look over in the little section for volume, there's not a conversion factor that goes directly from feet cubed to inches cubed. But I do know that 1 foot is equal to 12 inches. So here's my conversion. I need the inches cubed on top. So I've got 12 inches cubed is equal to 1 foot cubed. And you need to make sure that that cubed part includes the 12. So 12 is cubed as well. So you see the feet cubed on the top and the feet cubed at the bottom cancel out. And so you're left with 864 inches cubed. No problem. All right, convert 2,000 foot-pound force to BTU. So those are units that you're probably not, well, you're not familiar with BTU, right? Probably. Make sure that pound force, pound mass, you realize that there's a difference between those two. All right, so, when I'm faced with a problem like this, I go to my conversion factors and I just look for something that could be useful to me. And there it is right there. I've got a direct conversion between those two units. So I need BTUs. I need to just make sure that when I do my calculations, the BTUs are going to be in the numerator. And the foot-pound force, those two things cancel out. One's on the top, one's on the bottom. And so all I'm left with are BTU. All right, properties can be related to one another. And so if we know a handful of those properties, sometimes one, sometimes two, we'll talk about how many we need to know. If we know a handful of the properties, we can figure out any other property that we want to know about the system. And we only are familiar with three properties, temperature, pressure, volume at this point, but there are a lot of other properties that we're going to talk about in this class. So if we know a handful of them, we can figure out any other property that we want to know about the system. So that's very handy. Properties can be classified as extensive or intensive. And the reason that we need to differentiate between those two things is that intensive properties are the ones that are going to allow us to fix the state of the system. In other words, given these properties over here, this handful of properties, we'll be able to figure out any other properties that we want to know about the system. All right, so extensive, intensive property. Extensive property is dependent on the size of the mass of the system, and not surprisingly, intensive properties are independent of the size of the mass of the system. So we've got three properties. We've got temperature, pressure, and volume. So let's see which one of these camps those fall into. We'll start with the easiest, volume. I think it's pretty obvious that, well, volume is absolutely dependent on the size of the system. But what's not as obvious might be temperature and pressure. And they end up falling in the intensive property camp. So if we think about it, like the room that you're in is probably about 25 degrees Celsius, average of 25 degrees Celsius. So if I took the temperature, if I'm thinking about the temperature of all the air in this room, it's about 25 degrees Celsius. And then if I'm interested in this little pocket of air right here, if I could draw the boundary around just this little tiny pocket of air right here, temperature should be still about 25 degrees Celsius, right? And the same with the pressure. So temperature and pressure are intensive properties. Now, because intensive properties are useful for fixing the state of the system, might be useful to, if we had an extensive property, let's convert it to an intensive property. And the way that we do that is we just divide by the mass. So you express it on a per mass basis. So let's take our volume here. If we divide the volume by the mass, we get specific volume, so units of meters cubed per kilogram if we're in SI units. You'll notice that this is the inverse of density. We could use density. We're just, it's more common to use specific volume as opposed to density when we're talking about thermodynamics. All right. Now let's talk about a process. So a process is the so it's a change from one state to another. So it's the path that you take, or it's the way you get from one state to the other. Okay, so we're going to be looking at expansion and compression within a piston cylinder. So you see the gas or liquid. So my working fluid, I've drawn this red line around, that's my system boundary. So the working fluid, the gas or the liquid, that's my system. And as the piston head reciprocates between position X1 and X2, the pressure and the temperature change from P1 T1 to P2 T2. All right. Well, I hope that was helpful. We'll see you next time.